Today I have 10 different quadratic equations and I will guide you through how to solve them all with these three methods right here. In the first equation right here, I notice that I have x squared term and x term and no constant term. And then I know that I will use the zero product rule. So then I have to factor out x from these two terms. So I write x before a parenthesis and then equals 0. Inside the parenthesis, I write x from the first factor because x times x equals x squared. And then minus 1 from the last term because x times minus 1 equals minus x. And then I use the zero product rule. One of the factors must be equal to 0, so either must x be equal to 0 or the whole parenthesis equal to 0. And if the whole parenthesis will be equal to 0, then x have to be 1, because 1 minus 1 equals 0. And then we have our two solutions to this equation. Next equation. Here I notice that I have x squared term and x term and no constant, exactly like the first equation. So you can do it with the zero product rule again. And method 1 is to only factor out x, like we did in the first equation. So you write like this. And then what's left? We have minus 2x from the first term and then plus 6 from the other term. Either must x be equal to 0, and then we have x equals 0. But if you do it like this, then it's hard, a little bit harder, I think, to realize what x must be for the parenthesis to be equal to 0. So if you can't see it right away, then you can take out the parenthesis and write it like an own equation. The parenthesis equals 0, and then solve it by maybe adding 2x to either side, to both sides, and then we only have 6 equals 2x, and then divide by 2, and then we have the other solution. This is one way, but instead of factor out only x, you can factor out more things if you want to. So the method 2 is to factor out minus 2x instead. I choose to factor out a negative number because I think it's easier if x is positive when it's inside the parentheses like this. So from the first term we have x left because minus 2x times x equals minus 2x squared. And then from the next term we have a negative number left because we have a negative number before here. So we have minus 2x here and then times negative 3, then we have plus 6x. So you can write it like this. And then the zero product rule tells me that either must minus 2x be equals to 0 and then x must be 0, or the parenthesis must be equal to 0 and then x must be 3. Next equation. Here I got x squared term and x term and constant term, and then I know that I can use the quadratic formula to solve this one. And with the formula, if I can get 0 on one side, then I can just put in the coefficient like a, b, and c inside the formula. But to start, I of course take away 12 from each side like this. So I get 0 here and write it like this. Then I look at this coefficient. You can use the formula with this coefficient, but I think it's easier if you can just cancel it. If you don't have any coefficient before x squared, you get lower numbers inside here. It should be easier to solve this. So I divide everything with minus 2, and then I will get a much shorter and easier equation. I got x squared. I got minus 5x instead of plus 10x, and then I got plus 6 equals 0. And now I know that the coefficient here before x squared, it's called a, is equals number 1 because we have an invisible number 1 before x squared. And if a is 1, and then I can just cancel out these multiplications with a in the formula. So in the formula, I cancel them out, and then the formula is much shorter. Now I place it in the formula. So minus 5 is b, and plus 6 is c. So I write x equals, I put in minus, and then minus 5. And of course, minus and minus becomes plus, so you can, of course, write plus at once if you want to. Then plus minus, and the square root. I take 5 squared, and here, because it's squared, then it will always be positive here, no matter if I place a negative or positive number at the base. So here, you don't have to write this negative sign. So you can just write it like 5 squared or 25. And then minus 4 times our 6, which is c, like this. And then I divide by 2, because 2a equals 2 when a is cancelled. So this will be 5 plus minus square root of, we have 25 minus 24, and then divide by 2. And this will be 5 plus minus square root of 1, and then divide by 2, and then 5 plus minus square root of 1 equals 1, because 1 times itself is 1. So here we have the two solutions. x1 equals 6 divided by 2, if you use up the plus sign, and then we have 3. And x2 equals 4 divided by 2, if you use the negative sign, and then we have 2. So this is the two solutions. Yes. Next equation. Oh, here is a simple one. We have only x squared terms and constant term, and then the only thing we have to do is to isolate the x. So we add 4 to both sides. Then we have x squared left at the left side, and then on the right hand side we have only 4. And then we take the square root. It's opposite to raising a number with 2, of course. And then we cancel the square root and the exponent, and then we write x equals, and don't forget the plus minus sign, because it is two solutions here, so plus minus square root of 4. And of course you can write it like 2 at once. So x equals plus minus 2, we have our two solutions, x equals 2 and x equals minus 2. Equation number 5. Here we have x squared term and x term and x squared again. And then we don't have to use the quadratic formula, because if we only have x squared term and x term, we can use the zero product rule. So we have to send over all terms to one side and then take minus x squared on both sides. So we get 0 on the right side like this. Of course, we have minus 3x squared at the left instead of minus 2x squared. So now we can factor out x, but I think it's easier if you factor out a number 3 as well, because we have 3 here and we have 3 even here. 3 times 2 equals 6. And it's easier if you also factor out the negative sign. So I write it like this, minus 3x. And then the parenthesis equals 0. And inside the parenthesis, what's left from the first term must be x. Because if you multiply these two terms with each other, we've got the first term. And then we have the second term. And then I know that if I took away a negative sign here, then I must have a negative sign inside the parentheses for it to be positive when I multiply these factors with each other. So I write minus, and then the number is 2. So if you multiply these with each other, negative times negative becomes positive. 3 times 2 becomes x, and then we have becomes 6, and then we have the x. So this is correct. And then the first factor, if this will be equal to 0, then x must be 0. Or the second factor, if the parentheses will be equal to 0, then x must be 2. And there is the solutions. Equation number 6. I look at the terms here. We have x squared terms and x terms and constant term. And then I know I use the quadratic formula, of course. We have to get a 0 on one side. So to get this, I will add 2 to both sides on the equation and rewrite the whole line like this. Then I know that the coefficient before x squared equals 1. And then if a equals 1, then we can cancel out the a's in the formula like this. I know, of course, that b equals 3 and c equals 2 in the formula. And then follow the yellow arrow. To save some time, you can calculate the discriminant, the thing inside the root here. Then it will save you some time and some space on the paper. So I put in number b as b, so number 3, and then as c I put in my number 2 here. So I start to calculate this one, and I got like this. b, so we have b equals 3, so we have 3 squared minus 4 times 2. And then it will be 9 minus 8, and then the yellow thing will be equal to 1. Now I put in everything inside the formula, but the yellow I will only write 1 here. So x equals minus 3 plus minus square root of 1, and then divide by 2. Okay. Then we have minus 3 plus minus 1 divided by 2. And then we have our two solutions. If we use the minus sign, we have minus 3 minus 1 divided by 2 equals minus 4 divided by 2, and then it equals minus 2. And the other solution will be like this. We got minus 2 divided by 2, and then it equals minus 1. So the two solutions are minus 2 and minus 1. Equation number 7, 2x squared minus 3 equals 0. And I know that I have x squared term and constant term, and then I can use isolating the variable, the first method here. So I send over 3 to the other side and got 2x squared equals 3. Then I divide by 2 to get rid of the coefficient before x squared. And then I got x squared equals 3 halves. And of course you can write 1.5 if you want to. Then I can take the square root, no matter if it's a fraction or a whole number. It's the square root. So I take the square root on both sides. I cancel the square root and the exponent on the left. And then x equals, don't forget the plus minus sign, and then square root of 3 halves. If you have a calculator, you can put it in and get an approximate value for this. But this is the exact value, square root of 3 halves, or 3 halves raised by 1 half. To raising a number with 1 half is the same as taking the square root of that number. So the two solutions are these two. Number 8. We have x squared term and constant term and x term, and this equation is a bit harder. I know that I will use the quadratic formula, so I send over 2x to the other side and then 16 to the other side by taking the inverse operations like this. So I got 4x squared plus 2x and minus 16 equals 0. Then I know that a equals 4, b equals plus 2, and c equals minus 16. To save some space, I will evaluate the discriminant, the expression inside the root first. So I call it d to save a little more space, and then I write d equals, and then I take b squared minus 4 times a and times c, so like this. Then I know that I have 4, and then we have plus because minus times minus becomes positive, and then 4 times 4, and then 16 is also 4 times 4. 4 raised by 4 equals 256, so this will be equal to 260. Okay, I plug it all inside the formula here, so x equals minus 2, and then plus minus, and then we have inside the root I plug in 260, and then divide by 2 times 4. So the number 2 here was the number for b, and the number 4 here was the number for a, like this. Then we have our two solutions, like this. But you can write them easier, because when we have the square root of a big number, then you can take out some squares if you can. And I know that 260 is, you can divide it by 4, and 4 is a square, it's 2 raised by 2. So I can write like this. Instead of the square root of 260, I can write it like this. I take 2 times 2, it equals 4, and the thing that I have left is 65, because 4 times 65 equals 260. And then I can write them as two factors. I have one factor with the square root of 2 raised by 2, and then one factor, the square root of 65. In the first one, we only have 2 because the square root and the exponent cancel each other out. And then we got 2 times square root of 65. And when we plug in this into the formula, we have x equals minus 2, and then plus minus 2 times square root of 65, and then divide by 8. And then I can see that I have a factor 2 in this term, and in this term, and in this denominator also. So I can divide both the numerator and the denominator with the 2 to make it easier. And then I got minus 1 plus minus, and then only square root of 65, and then divide by 4. And then we have our two solutions. Do you miss the number 9 and 10? Please write a comment and tell me. I'm not even sure that anyone's looked at the first 8 equations. So now it's time to go to bed, I think. Bye bye. See you.